Mark, I understand this is your first Hannover Messe.
Yeah, that is definitely true. I am a Siemens newbie still, I think a year in. Loving the experience. Obviously it's crazy, but it's crazy in a good way. Now, technically it's not my first Hannover Messe because I was here as a 14-year-old kid with my dad who had a small stand and I got to roam these massive halls in wonder. And now as an adult, I get to come back and wander in equal wonder. So yeah, it's awesome.
Now you mentioned you're relatively new to Siemens.
Yes.
From an outside-in perspective, what do you see going on?
So I mean, what I see, if we start with our customers, which I think we should always do, is our customers live in interesting times, I say, right? Literally the meaning of the Chinese proverb. In many ways, there are fantastic opportunities, right? In general, our customers' customers want more individualized products, whether that is individual medicine or we have the pop-up stand below on fast-moving consumer goods. If it's beverages with regional flavors or occasional flavors, our cars are getting to be a customized individual experience as well. So we have this, in some ways, complexity coming in, but opportunity to really tailor-make the product experience. We have, unfortunately, uncertain times in the world, right? Tariffs coming in, supply chain shortages, nearshoring of production back again, and then we have technology changes, and not just AI, although that's what everyone talks about. So if you look at sort of that list of things, from our customers, that's both an opportunity and a challenge.
Correct.
So I think like our job is really to say, how do we harness that complexity? Instead of making it, I mean, I love, sort of the KISS, right? Keep it simple, stupid. But that's also hiding the real value of complexity and what you can use complexity for. So I think a lot of what's going on is, how do we harness this complexity? And that's what we see. And me having spent previously a lot of time on the product development side,
right,
we've been really good in digital product exploration. So we are in the heart of Germany. You used to crash test a physical car.
Correct.
Right? A physical prototype car is expensive. $500,000 to $1 million a piece. You smash them.
You had to build it the first time.
You have to build it the first time.
It was a year or whatever, right?
Exactly. So you don't crash test too many, you're very careful. But that's the opposite of good engineering. Good engineering is asking as many questions as humanly possible.
Before you build anything.
So today we virtually crash test hundreds of thousands of different variations of a car, and we take the first production car off the assembly line at $20,000 a piece and crash test that, right? So massively more design exploration, but then what happens so that's product development, right?
Base, yeah.
Massive design exploration, very digital. Then you hit the factory, and it's like, how do I do design exploration in my factory? Which very few people do. So I ask all my customers right now, when have you last run 100,000 variations of your factory? Different setups, different tweaks.
You might optimize something, you might find something you never thought of.
That's exactly right. You might ask a stupid question, right?
And get a very interesting answer.
Exactly. So I think that's back to harnessing the complexity. We're now in a place where you can build a digital twin of your factory, and you can treat your factory as a product, right? 100,000s of variations. And increasingly over time, and this is still where we're pushing the frontier, that digital twin will then go into production.
Correct.
Right? It will be coupled to real-time data, so it actually knows what's going on right now. And then you can do what ifs, right? What if I tweak this in real time in production? You can catch an AI hallucinating because it might say, I would suggest that you do this.
Which may not be
right?
As unintended consequences somewhere else in the supply chain.
So AI is fantastic, right? When you couple it with this foundational understanding of what's going on, what's the deterministic process look like, what would work, what wouldn't work. So I always say AI kind of adds a little bit creativity, but you don't want too much of it. Right? So you want that coupled with this determinism.
Look at what you announced here this week. So you have the Eigen engineering agent.
Yep.
You have comprehensive digital twin.
Exactly.
You have digital threads.
Yep.
You have the digital twin composer.
Yes.
Yada, yada, yada.
Yeah.
To me, I always say the technology is the easy bit.
Yep.
But it's how do you how do you join
Yeah.
the digital twins?
Yeah.
How do you join the
Exactly.
dots to get that?
And what's the business value of them?
Technology is simply the
Yeah.
enabler, the
Exactly.
convergence to
Yes.
enable that,
Correct.
but you have to have a business
Yeah.
reason, and you
Yeah.
have to. It has to have an ROI. It's not just technology
No,
for the hell
no,
of
that's
it.
right. That's exactly right. So I think one of the big parts of my job is doing exactly what you just said. How do we bring this together? So I have this industrial operations system, right?
Yeah.
The operations software at Siemens, which is essentially all the software we have to design a factory or a process plant,
Yeah.
which is where that digital twin comes in. But then it's also the software that then runs the factory. So your classic DCS or SCADA system, your MES system, and increasingly your AI and your analytics, right?
Wait till you
Yeah.
unleash open claw
Yeah.
across the whole thing, right?
Yeah, exactly, right? So it really is building, we are building a modular interoperable system so that, as you said, these things do fit together. But also production is brownfield and heterogeneous. And I would wish that there were 100% Siemens shops, but they're not.
Unfortunately, not in the
No,
real
but that's
world.
just not the real world,
No,
right? And
you
it
know.
shouldn't be. So how can we, land and add value and connect to the stuff that already exists, but how can we sort of build a broader vision?
I saw you were at NVIDIA GTC
Yes.
a couple of weeks back. We
Yeah.
didn't meet,
Yeah.
but what you saw there in terms of enabling technology, any takeaways from that?
This year at GTC, sort of having been on the call it the GPU compute bandwagon for quite a while, right? This year, I would say, obviously, physical AI was in the front, right? And there was a lot of excitement about that. And I'm also excited about that, but I also think that's hitting exactly that sort of, because we get excited about humanoids, and there is a great place for humanoids, don't get me wrong, but it's not always that our human form factor is the optimal form factor for whatever needs to happen. So I think we're kind of, getting a little over our skis in that part of the game.
So around here with
Yeah.
Siemens, I was off in Erlangen before Christmas. You had some humanoid demos there.
Yeah.
I find the technology and the ecosystem incredibly fascinating.
Yes.
But to your point, Hall 25, we're in Hall 25, there's like 20 different humanoids. Incredible technology.
Yeah.
But not necessarily ready for prime time in the factories.
No,
just yet.
but even if they are, right, if you look at, say, automotive production, and you need welding, right, you don't need a full humanoid. You already have robot arms that can do exactly what they, so it's a little bit like, I'm also still excited about additive manufacturing, right?
Correct.
But there's still a role for I-beams, there's still a role for sheet metal, there's still a role for CNC machines, right?
All of this stuff isn't going away.
And it's the same for me for humanoids, right? It's a great new capability, but it fits with all these other things we already have in place, and it complements some of them.
Well, it was Max in Erlangen said a point. He said, look, if we can put in a fixed robot,
Yes.
robot arm, robot
Exactly.
conveyor belt, robot whatever, or an AGV or whatever,
Yes.
we will. That's
Yep.
default. It's for those sometimes tasks that we don't do repetitively.
Exactly.
I don't want to hard code it with
No,
a fixed robot.
that's right.
I want somebody to turn up, learn on the job and do it.
That's the sweet spot.
When you're chatting with customers, what's next?
Yeah, so in short, we've gone through a wave where we automated our factories,
Yeah.
but it was a lot of, call it, fixed automation. Right.
Agreed.
Right.
You kind of hard coded it.
Exactly. So I think the next wave that we're going to is really autonomous factories that are much more nimble, much more ready to change. Because as you said, it's multiple things. So it could be that it's a tariff and now I need to switch to another supplier. That supplier's tolerances or alloys are slightly different. Now I need to make a product change, right? I only have a week to do it. How fast can I go from, small product change, my engineering BOM changed, to my manufacturing BOM changed, to my bill of process changed? Or if you're in process industry with, if you are, Coca-Cola or Pepsi, and a flavor hits at the right point in time, or as our pop-up factory, I want my Gatorade in the color of my team
For the
at
World
World Cup, right? So I'm Danish originally, I want a red, Gatorade, and all of a sudden it spikes. How fast can I adapt that production? So that I think is the adaptive. That's not the fixed automation. That is I can make a product change or a quality change or whatever it is, very rapidly permeated through my factories, permeated through a global footprint, right, and dial things up and down. That's where I see we're going. So and it builds on top of what we already did.
Yep.
You could not do this without automation.
No.
You could not do it without an MES system or similar.
And then if I may, it's the convergence of technologies,
Yep.
because you'd say, well, the amount of compute that
Exactly.
I need to do that at the edge,
Yep.
I didn't have 2
Yep.
years ago. Now I do.
No.
And I have industrial 5G for
Yep.
low latency comp.
It's exactly right.
It's that stacking of
That's exactly.
technologies to come up with a solution.
And then AI can help us be more adaptable. And I see it as an AI that comes in and becomes very distributed. What do I mean by that? There are some people that would say, hey, we're going to build a layer and then we're going to run all our AI on top. That's not the world I am seeing. I am seeing, so this example I talked about, your bill of material. We have agentic capabilities now that can help you go from one step to the other. So it would say, I know that in Poland you have this bill of process and these specific regulations. I know it's slightly different when all of that exception handling before was very manual. We can now embed in that process an AI stream. Then the agentic planner can pick that up and talk to that AI. And they are on top of a deterministic planning system and knows where to slot its stuff in. They can now talk to your asset management system that also has embedded AI in the digital twin and say, hey, you should be careful because I have downtime, and you can't push the machinery more than this. So I see these chains being built where we're building the agentic capabilities in. Physical AI is the same. It will be on that device, right? Knowing what that device has of capabilities, and then it all gets stringed together. So I think that's the world I see emerging, sort of step by step. And I think this paradigm is in some ways coming together similar to how we are as human beings. So if you take a city, we're not asking people to be stupid, right? So back to people are innovating in their silos. Smart people will do smart things, right? And you will make your own decision on how to traverse a city or how you optimize your space that you're living in or working in. But then you need to have an architecture, you need to have an infrastructure, there needs to be a water grid, there needs to be a road grid, and so on, for that big picture to fit together. So I do think you need to, as intelligence becomes more pervasive, you have to have that duality of don't stifle smartness at the edge and in the silo, but at the same time have a clear architecture for how the things fit together.
And you can game it out through simulation, and that if I do this, are there any implications?
Exactly.
And look, it is fascinating.
Yeah.
But as I say, the pace of change is incredible and scary at the same time.
Yes,
right?
it is. It absolutely is.
Hey, good stuff. Thank you very much.
Thanks, Kevin.